Today, we're diving into one of the most frustrating barriers in modern AI. We're going to explore why even the smartest models seem to have a terrible memory, and more importantly, how some brilliant researchers have found a new way to smash right through that wall.
You know the feeling, right? We've all been there. You're deep in a conversation with an AI. You feed it a long document, a big chunk of code, or a really complex question, and it just starts to lose the plot. It forgets key details from the beginning, it gets confused, and the answers just fall apart. So why does this happen, even with the most powerful models out there?
Well, this chart from a new MIT paper shows you exactly what's going on. As you give a top-tier AI model a more complex task, its performance just absolutely nosedives. The researchers have a name for this: context rot. It's the decay of an AI's ability to reason when its short-term memory just gets overloaded.
But what if an AI didn't have to rely on that fragile, limited short-term memory? What if it could handle documents, code bases, or data sets of almost any size with perfect recall? Well, that's not science fiction anymore. A new technique is making it a reality, right now.
So, to really get what a huge breakthrough this is, we first have to understand the fundamental memory problem that every single large language model is up against. It all comes down to this thing called the context window. Think of it as the AI's short-term memory. It's the absolute maximum amount of information it can juggle at any one time. Now, tech companies are in this massive arms race to make this window bigger and bigger. But as we're about to see, just making it bigger doesn't actually solve the real problem.
And that's because it's not just about how long the text is, it's about how complex the problem is. Look, on a simple find the needle in the haystack task, a model might do okay with a long document, but give it a really complex reasoning task, one where it has to connect different ideas spread all across that document, and that context rot sets in way, way faster.
So the researchers at MIT had this incredible insight. They realized that instead of trying to build a bigger memory, the real solution was to completely change how the AI uses its memory. It was time to start thinking outside the context window. Here's a great way to think about it. The old approach is like trying to cram an entire library's worth of books onto one tiny little desk. It's an absolute mess, it's inefficient, and you're going to lose stuff, for sure. The new approach? So much smarter. You leave the library exactly where it is, and you just give the AI a library card. This way it can go search the stacks and find exactly what it needs precisely when it needs it. So how in the world does this library card actually work? Well, the technique is called a recursive language model, or RLM for short, and honestly, it is unbelievably clever. Instead of just feeding a giant wall of text directly into the AI's brain, the RLM loads that text as a variable inside a coding environment, kind of like a file on your computer. Now from here, the AI can actually write and run code to interact with that text. It's not just reading anymore, it's actively investigating the information.
Here's the breakdown of how that works. First, the whole document gets loaded up as a variable. Simple enough. Second, the main AI acts like a project manager. It looks at the big problem and writes code to break it down into smaller, manageable chunks. Third, and this is the recursive magic right here, it calls on smaller, super efficient helper AIs to solve each of those little subtasks. And finally, it takes all the answers from the helpers and stitches them together into one single comprehensive answer.
Okay, so it's a brilliant strategy in theory, but does it actually work in practice? Well, the results are nothing short of stunning. I mean, the difference is just night and day. On the left, you see that context rot we talked about. The standard model just collapses under pressure. But on the right, that's the recursive language model. Its performance stays incredibly high, even as the amount of information just skyrockets, handling way more than the base model could ever dream of.
Let's put some hard numbers on that, because this is wild. On a particularly tough reasoning task, the standard model just completely fails. It scores less than 0.1%. But the RLM, using that exact same model as its engine, scores a 58%. That's not just a little improvement. That is the difference between total failure and genuine useful capability. And here's the real kicker. You'd think this whole complex multi-AI process would be insanely expensive, right? But it's not. Because the RLM is smart enough to delegate work to smaller, cheaper helper models. The total cost is often about the same as, or sometimes even less than, trying to brute force the problem with one giant model. So it's better, and it's more efficient.
This is so much more than just a clever memory hack. In fact, the researchers argue that what they've really unlocked is a fundamentally new way for an AI to think.
The authors themselves say that the path an RLM takes to find an answer, The code it writes, the subproblems it creates, the way it puts the results together, that whole process is a form of observable reasoning. So instead of just getting a final answer from a black box, you can actually watch the AI's strategy play out, step by step.
And that leaves us with a really fascinating final thought. We've been so focused on building AIs that can answer our questions. But this new approach builds AIs that can create their own plan to find the answer. It's a huge shift from just knowing stuff to knowing how to figure stuff out. So the real question is, what happens next? What becomes possible when our AI assistants learn not just to answer, but to strategize?